This is a review of yesterday. So I'm going to remind you, you can use inverse by saying that, or you could put a little arc in front and say that, and they both would mean the same thing. But what do they mean? So when they say, please make a, go off to the side or something and write this, y equals arc sine of negative 1 over root 2. Now, this is a strange one, but you should be able to, from what you memorized the other day, figure out which two quadrants are even allowed, and then in which one is it going to be negative, and then just draw me the triangle. I understand you may not be able to figure out the angle that's involved, but just draw that. All right, circle trig involves a ton of little facts you have to know, like which quadrants things are positive and negative in. And that comes into play here because if we do ASTC, and we also have to know which two quadrants is arcsine even allowed in. Did you know that it was these two quadrants that it was allowed in from there to there, and therefore these two are out? All right, so those are the only two that arcsine are allowed in. And now I've got to figure out which of them it's going to be negative in. Well, then it can't be here because it would be positive. So then I draw my triangle here. Sine is opposite over hypotenuse. Is there a triangle that has sides like that? Remember which one it is? Would you agree that a 1, square root of 2 triangles looks familiar? Then, do you get that that's 45 degrees? Then, do you get that that's pi over 4? And then, I know some of you are waiting for this last shoe to drop. What's the last shoe that needs to drop? Because the answer isn't pi over 4. Yes? It's negative pi over 4. Because you remember how when we're doing inverse trig and you go this way, you are going in a negative direction. This is negative pi over 2. And this is the negative zone. Whereas over here it's the dead zone because nothing will ever be done over there in inverse trig. Okay, cool. So then you knew that the answer was 45, and not only that, negative 45, and not only that, it's pi over 4 and negative. There we go. All right, so to step this up a notch, we have to be able to do this same thing, except this is going to seem weird. I'm just going to add something to your problem. You should do the same. In front of it, I'd like you to put tangent of all that. Now, don't we normally have tangent of an angle? Didn't that just tell us an angle? You know, all this part, it was an angle. Anytime you're doing inverse trig, see it says arc here? That means you're finding an angle. That's basically saying, what's the tangent of that angle? And what angle was it? Negative pi over 4. So it's really saying, what's tangent of negative pi over 4? And hint, you don't have to redraw a new triangle. We've already got it. It's right here. So that's, what's tangent of that? Opposite over adjacent, negative 1. Do you get that adding an extra function out here just adds one more little step? You just have to, at the end, go, okay, now that I found the angle, I can do tangent of the angle, and you've already got the triangle drawn. Okay, so tangent, TOA, opposite over adjacent, negative 1 over 1, so that's just negative 1. So the nested ones are really not that scary. All right, I'm going to give you another nested one. This would have been from the homework. I'm not going to make you go find that from yesterday. But if we had had tangent of inverse sine of root 3 over 2. Would you please start on the inside as you do all hard math problems? Draw the triangle, label the sides at angles, and then at the end, just do tangent of it. So many little pieces of this puzzle. Lucas, name one thing that would stop a kid if they didn't know. Like, what's one thing you're going to be doing that if you didn't know this, you'd be stuck?
Well, you have to know which quadrants it can go in.
Good. And we just said it a second ago. Inverse sign's only allowed where?
Inverse sign is only allowed to the furthest to the right, those two.
Those two. So then these are out. If you didn't know that, you couldn't do this problem. So many little things you have to know. All right, name the next little thing that you have to know.
You have to know.
How about this? Between those two quadrants that are left, how are you going to tell which one it's in? Because inverse sine only has one answer. I'm going to write this. Sine of the angle equals root 3 over 2. And those used to have two answers, but it's only going to have one because sine is positive.
Yeah, so wouldn't it go in the top one?
It would. It would go in quadrant 1 because it's positive. Sine, if it was down here, would be negative. So that's out. So then sine is opposite over hypotenuse. Ooh, I know this one. 1, 2, root 3. Davis, what's across from the square root of 3? Like over here. That's a 60, but say it better.
60 degrees.
Okay, say it better. In radians.
Oh, pi over 3.
Pi over 3. Now, double check. Is there any chance that it's negative pi over 3? No, because we're in quadrant 1. So that is just pi over 3. But then why, if you said the answer is pi over 3, why do you get the problem wrong? Because you still have to do the tangent of it. Okay, so now tangent of the pi over 3. I don't have to redraw a triangle or anything. I just have to go tangent is TOA, opposite over adjacent. So it's root 3 over 1, which is root 3. So that's the final answer. How many of you had root 3 before I even said it? Okay, good. You get nested ones. Then, here's the next thing I have to teach you. I told you that on sine, everybody graph sine just real quick, just a sketch of sine, except we need to go 2 periods, one on each side. Next, quick labels. This goes to 1 and negative 1. And now, we're just going to label this spot and this spot, which is pi over 2 and negative pi over 2. Why aren't you labeling all of it? Because I'm going to cut it off. Right there. Do you remember why I'm cutting sine off right there? Yes?
So it's a 1-to-1 function?
So that this part of the function is a 1-to-1 function. It passes the vertical and horizontal line test. Cool. So this is still the graph of sine. I just kind of cut it off to only part of it. Would you agree I have graphed just a part of sine? Then, here is your challenge. The other day, one of the teachers that teaches AP Calculus said that on the AP Calc test, the kids were asked to graph what inverse sine looks like. Well, it doesn't look like this, but that right there would help a lot to try to graph inverse sine. So, I'm going to show you what those kids should have drawn if they were supposed to graph inverse sine on the calc test. I'm not saying this was an actual question on the test. It might have been on a practice test, but either way, they would expect you to know how to graph an inverse. So this would make you really combine a couple things. You have to know what sine looks like. You have to know what part of sine has an inverse. And last, you have to remember what the heck is an inverse. What's the key about inverses? What do they do? It's not just a reflect. I get what you're saying. It's not just a reflection. Yes, kind of. What's the key about inverses? This becomes this, that becomes that. Yes? Yes. If x becomes y and y becomes x. Okay, so what does that mean? So I'm going to put this here, and I think you'll start to understand. What just happened? The y values on sine just became the x values on inverse sine. Sammy, I know they're just so comfortable you forgot they're in, but you need to take those out. Okay. So the inverse sine has its x becomes its y, so its y has to also become its x. All right? You should figure out what goes here and here then, shouldn't you? Did you figure out that this has to be pi over 2 and this has to be negative pi over 2? Isn't that weird? But doesn't it make sense? The x's became the y's and the y's became the x's. And last, we have to do what somebody else said earlier, and I kind of poo-pooed it, but you were right, but we just weren't ready for it yet. How do we actually see what this looks like? I'm going to make this a little more curvy. The original one, just going to make it a little more curvy. Well, doesn't the graph just reflect across the line y equals x? So it goes like that. Now I know that's a very subtle difference. They both kind of look like waves, don't they? But can you tell where this one sticks up above the line? This one's kind of going below the line over there. There is your graph of inverse sine. All right, that's important. You got that? All right, so what did I do again? I took part of sine, labeled it, then I made inverse sine by flipping the x and y labels around, and then the actual curve I got by reflecting it across the line y equals x, that dotted line I put in there. Okay, let's see if you really understood that. Here's cosine. Y equals cosine of x. Everybody graph cosine of x. You should be able to graph cosine of x. You should be able to cut off the part that isn't going to pass the vertical and horizontal. So just start with cosine and go in both directions. Just a little ways. Then cut off the part. We want to stay close to home, which is the 0, 0 spot. We want to stay close to that and cut off the part of the graph that won't work. We only want the part left where it'll pass the vertical and the horizontal line test. Label that really well, and then graph inverse cosine over here. Pausing for a second. Okay, so was your challenge to make inverse cosine. Well, first off, you gotta pick the right part of cosine. This is the part of cosine that would pass the vertical line test and the horizontal line test and be close to home. Now, you could have technically picked this part over here. Why don't we pick that? It's just more complicated because it's all negatives. All right, so we usually pick, well, not usually, that's the part we pick, which is between 0 and pi. You may remember from my master drawing that inverse cosine's only allowed in here from 0 to pi. Okay, so it looks different when it's in a circle, but all right, so now I'm going to label it from 1 to -1. And now I'm going to say switch them around. The 1 and -1 were on the y-axis, so now they're going to be on the x-axis. And the 0 to pi was on the x-axis, so now it's going to be on the y-axis. So now this graph is weird. No doubt about it. So what I would do is I would take individual points and say, okay, where's that point gonna go? Otherwise, this is gonna be really hard to draw. Okay, it has to be a reflection across the line y equals x. Kind of looks like that. All right, so what is this spot right there on cosine? What comma what? Yes? 0 comma 1. So it turns into 1 comma 0. See, this point here at 0 comma 1 turns into 1 comma 0 because x and y flip. Okay? What's that spot right there? What comma what? Isn't this pi over 2 right there, I'm pretty sure, right? Pi over 2 comma 0. So 0 comma pi over 2. And then this part went negative down here, and that's at pi comma negative 1. This spot right there is at pi comma negative 1. So it's going to be negative 1 comma pi. Now it's obviously not a straight line though. And that's where I wish I were a better artist. There. Good enough. I would have given you credit on the test. Yes.
Why does it just end? Because it doesn't, sine goes on forever. Why
Yeah,
does
yep.
this?
Why?
One of these
Because
two-
we stopped it. Remember, we stopped it at the part where we didn't want it to go past here. Why didn't we want it to have this part? Because it wouldn't have passed.
Vertical line.
Well, the vertical would have still passed. It wouldn't have passed the horizontal line test anymore. Okay? And if I reflect it over here and I let it keep going, then it wouldn't pass the vertical line test.
Yeah.
Okay, so that's why we stop it. Yes? I believe I've done it correctly. Now, it is humanly possible that I haven't got it. Do you mean you think it's down here?
No, I mean,
The concavity? Like, do you think it's like this? Is that what you're saying? I think I've done it correctly. But I can guarantee you that I've done this, this, and this correctly. All right. So if you really, really want to know, graph it on Desmos. And graph it, graph at Desmos will tell you. But I think I got it. Okay. So that's weird, but not incredibly hard. Like, you guys get this part, don't you? That you only go between in the part that has a passes the vertical and horizontal line test. I hope you get that part. And that means these four numbers are known. You know what these four, and this is 0, 0, which is, I guess, the fourth number. And from there, I would have taken individual points. This point, this point, and this point. And you're supposed to remember what inverse means. It means x changes to y and y changes to x. So if you name each of these points, this one, for instance, was pi over 2 comma 0. It became 0 comma pi over 2. All right. Could you do the same thing with tangent? Yes, and I'm not going to waste your time with that. You would just take regular tangent and you would say, what does that go between? Well, pi over 2 and negative pi over 2. You're supposed to know that from our last test. It goes 1, negative 1. And you flip it. This one's actually just too easy. This one goes to pi over 2 to negative pi over 2 labeled here. And from negative 1 to 1. And well, maybe it's not too easy. How about that? I start with this and you tell me, what's the line look like? Remember, it's a flip across the line y equals x. And I didn't draw it perfectly, so I guess I'll draw this a little more cleanly. And then you see if you can draw the inverse of it. That's what tangent looks like in the first place. Has to reflect across the line y equals x. Teachers suffer from this sometimes. I've been doing this a long time, so to me it seems like obvious, but yet I totally get it might not be for you. All right, try to graph inverse tan. If this is tan. Okay, so if you haven't already done this, I put in the dotted line that goes like that. And where the one's high, the other's low. Okay, next thing I'd do is I put in the asymptotes because there were asymptotes here and here, and everything flips. So if there was asymptotes that were going up and down, now the asymptotes are going this way. Next, I said take some points like this and this and this. Maybe even take a point that's like way up here and way down here. And think of what they're going to do when you change their x and their y around. Well, if you're flipping across that line, this dot is in exactly the same place as it was because it's on the line. And so is this dot. And so is this dot. They're all on the line. So it seems like they should stay right on the line. So exactly where is this dot? That's at pi over 4. And that's at a half. So then it's going to be 1/2 comma pi over 4. Pretty much right in the middle there. It's right in the middle there. And if you have to stay inside the asymptotes, I bet you can connect them. Oop, my curve is terrible. There. Again, I am not an artist, but it's got the main pieces right. It's got those 3 points that are, when you flip them, they're on the asymptote, or they're on the y equals x line, so they're just going to stay the same. And it used to be heading in this way and that way, so of course it's going to be heading this way and that way, which, doesn't that kind of make sense? All right. So there's graphing, and now we have one last set of things to understand. So let's go to this page. I should be able to have you do these. If you just think about the graphs we just did, the domain and range for inverse sine is the same exact thing as we just talked about. Figure out what regular sine's domain and range are. You know, the part that we said was okay for sine. So here's sine again. That's the part of sine that we allow. Then you should know what the domain and range of original sine is, and so you just switch them around. Figure out the domain and range of inverse cosine by figuring out the domain and range of regular cosine and switching them around. Now, this is going, I'd like to just do the domains and ranges quick, and then we'll do this arc sine of 4 question. All right. So this is regular sine. So its domain was negative pi over 2 to pi over 2. So that means the range of inverse sine was negative pi over 2 to pi over 2. When you're looking at the pictures, it's so much easier. If you have to, just make yourself a little sketch like this, and then you can be like, oh, that's not that bad. And what is the domain of this? It comes from the range of that. And the range of regular sine was negative 1 to 1, and it can touch those brackets. Oh, and it can touch these too, brackets. Just realized that was important. Let's even just skip tangent. Save you time. Inverse cosine depends on cosine. So I start with cosine. I graph regular cosine. And actually, I'm getting smart enough to go, that's all of cosine that I need. And I go between 0 and pi, because that's the part that passes the vertical and horizontal line test. And its domain 0 to pi. So then the range of this one is 0 to pi. And it touches. And this guy's range becomes this guy's domain. Did anybody have that before I said it? A bunch of you. Good. All right. Now, let's focus on this one because the last thing I have to teach you has a lot to do with this. So try this one. Remember, I wish I could just, it was so easy. It was just easy lessons. I get to go and work, answer emails, enter homework. It'd be awesome. This class is not an easy class. So what are you supposed to do? Well, by now, hopefully you're realizing this is one of those inverse trig questions. So my first tip to you is always to rewrite it as this. Sine of theta equals 4. And right there, you should notice something. Can I put it 4 over 1? Maybe that'll help you see. Sine is opposite over hypotenuse. Is that even possible? There is no way that that can work. Period. The end. Sine is never equal to 4. Regular sine isn't. What's the highest sine ever goes? 1. So when is sine equal to 4? Never. So there's no solution. Could have drawn this all out, but then hopefully you'd have got to the part where you're drawing it, going inverse sine is allowed here to here, and then you're like, sine is positive, so it must be here. Sine is opposite over hypotenuse, and then, wait a minute, that's backwards. Opposite is 4, and this is 1? That's not possible. You can't have them, therefore no solution. Does not exist. All right, let's do this one. I promise you, this one exists. But remember, in an honors class, sometimes the hardest answers are, there's no solution. Because you feel like you're just doing it wrong, but... All right. Inverse sine is only allowed here to here. Crossing off, crossing off. Next, I really do think it's a good idea to write this. Sine of theta equals -1/2, because it reminds you that's the root of this problem is we want an angle. See, we don't know the angle, and that's what we're trying to find is the angle. So then, it's got a big but though, but it's only allowed to be, since it's negative, in there. Normally this would have an infinite number of solutions, but we have to stay in here because inverse trig can only have one answer. And sine is opposite. Hypotenuse, I know this one. 1, 2, root 3. Remember me saying that these would be important triangles? Half the class didn't know the 30, 60, 90 triangle before this. We started this. Now it's like every day, 3 times a day. That's 30 degrees. But that's not supposed to be degrees, it's supposed to be radians, so pi over 6. And then you have to know that that is slightly wrong too. What's the final answer? Negative pi over 6. Because we're in the negative zone, and we don't go all the way around to here because there's no answer that goes past pi. If you ever give an answer that's bigger than pi, you're doing something wrong. If you don't want to even go through the dead zone. If you've watched The Walking Dead, you'd know that. Okay, negative pi over 6 is your final answer. And do you get if I slapped a tangent in front of this, it would actually be super easy to finish it right now? Tangent would have just been opposite over adjacent and I'd be done. You know, like the nested ones are just one more step is all. Okay, so this one's different because it has a variable, but other than that, it's exactly the same. So don't freak out. If it's a variable, I can tell you this. You still have to obey the rules about, you know, like where you can be for inverse sine. But variables, do you remember I said always put them in first quadrant? Do you get that this z could be negative and therefore, like, we don't, like, it's weird. You don't know where to put it, so default to the first quadrant. Keep your life simple. Put it in the first quadrant. It'll work. Okay, so it can't be here because arc sine can't be there. And when it's a variable, put it here. All right, from there, I'll let you label all your sides properly, all of your sides. And then at the very end, you just do cosine. Pausing. Tell me, what are the sides in this thing and where do they go? Like, use words like opposite, hypotenuse, adjacent.
So your z's are hypotenuse.
Okay.
And then 3 is your opposite.
And how do I do that as last side?
You can just do Pythagorean theorem.
I agree. I like the square root thing.
Yeah, so square root,
Which one's bigger, z or 3?
well, z has to be bigger because it's hypotenuse.
So I'll lead with that because when I subtract, I got to have the bigger one first, otherwise it'll end up being negative.
Mm-hmm.
So
it's square root z squared minus 3 squared, which is just 9.
there we go. Square root of z squared minus 9. All right. Are you glad now that I taught you this square root trick? It's, if you aren't using that, you're wasting so much time. All right. So then, what's the end? You just do cosine. Adjacent over hypotenuse. That's why we needed to find that. It's because it's the adjacent. And so then it's square root of z squared minus 9. And some kids think, oh, the answer to that is z plus 3. No, it's z plus 3 and z minus 3. And then you can't really do that. You can't pull both of them out. And so you can't pull out z squared plus and minus 3. That's a common mistake people think. No, don't try to simplify this. You can't. Okay, I could show you why, but it would take a long time, and I've explained it before. So that one cannot be simplified. Cosine is adjacent, which we just did, over hypotenuse, which is z. I put a slash through my z's because otherwise they look like 2's. And in some languages, or written in languages, they put a slash through their z's. So I think German is one of them, where you put a slash through the z. Anyway, I think it's a smart idea because otherwise your z's will look like 2's. There you go. Any questions? You may not have had it right, but do you understand it now? How many of you actually had it right? Okay. All right. Now, nasty. So, when you see one like this, you need to step back for a second and think, This is an angle, because any arc thing is an angle. Arc of anything, it's an angle. And this is an angle, and isn't that sine of an angle plus an angle? Didn't that come off of a sheet somewhere? Would it help you to know that I'm going to give you the sheet again for this next test? Aha! So clearly, we have to use this part of the sheet. So, that's the first thing I do is figure out which one is it. Well, duh, it's plus. So therefore, it must be the top one. And I would write that out. Sine of x plus y is equal to sine x. And I'm going to be replacing those x's and y's in a minute. Cosine of y plus cosine of x sine of y. No doubt, this is the hardest part of the test, is that we have to go back and use these things again. But this does not mean that we stop doing the inverse trig problems the same way. We do the inverse trig problems the same exact way. Yes?
But when you use cosine x plus y, because sine x plus y is different from cosine x plus y.
All right, hold on a second. Aren't we doing, the problem that they gave us is sine. Okay, all right. So that's why we're doing sine. So I know you see a cosine here, so you're thinking, what? Problems about cosine. But it's the sine on the outside of this angle and this angle. Now, that begs the question, what is this answer? Well, maybe I should go find that answer somehow. Like the same way I've been telling you all along. And when I find it, I'll be doing this. But I need to know what the angle is, because that's an angle. And that angle is really x. So once I find this answer here, it's going to become that. Okay, so now let's find that. So I go do all my little things like draw the circle in the right place. Where is cosine even allowed? So then I start, I think this is the best way to start. Cosine of some angle is 2 over 3. But that would have infinite answers. But it has to be up here, because that's where inverse cosine is allowed. I told you to memorize that on day 1. So that's where inverse cosine is even allowed. Then, these are positive numbers, which means it can't be here either. So then it must be right here. Man, how many triangles have we drawn since the beginning of this semester? Like 10 a day? And the semester's about 90 days long. 900 triangles by the end of the semester, probably. Okay, anyway. So cosine's adjacent. Hypotenuse. Is there a triangle that has a 2 and a 3? Yeah, it's just not one of the common ones, but that's okay. That's kind of the main new thing for today, is to remind you that you can find that third side this way. Square root of, and that's a 9, and that's going to be a 4, because it's, a squared plus b squared equals c squared. So that's a 9 minus a 4, which is really square root of 5. Cool. The last side is the square root of 5. Okay. And now, but how am I supposed to know the angle for that? You don't need to know the angle for that. You need to know sine of the angle for that. See? We never need to know exactly what that is, 22.6 degrees or whatever, who cares? I want the sine of it, but this is angle x. This is considered the x angle, this whole thing is the x angle. So I want to put an x above this drawing, and this tells me all about x. If I want the sine or the cosine or the tangent, this is the x angle. This whole drawing tells me the x angle. Over here, we'll make a separate drawing for the y angle. All right, so now I can do anything about x that I want, which there's two main things they want. They want sine of x, which that's easy, opposite over hypotenuse. So opposite is root 5, hypotenuse is 3, so root 5 over 3. And then I got to do y, which I'll do later. And then I do cosine of x. That's this one here. Cosine of x, well, it's pretty easy. It's given to me in the first place. Cosine is adjacent over hypotenuse, so it's 2 over 3. And I can just look in this triangle like normal. Okay. Would you please go figure out these two, cosine of y and sine of y, and you'll get them from this. Now, the question on the test last year that was like this was the one that was missed by more than half of the class. Okay, so practice this. It's not the same question as this, but it's like one of these where you got to go find stuff on the chart, bring it back in, and do inverse trig. This is the hardest thing. Like I know from last year, I remember this problem or one like it. So many kids got it wrong that I actually had a lot of retakes on that test. It was sad. So I need to teach this better this time. So we'll practice this more.
So if that's the hardest thing on the test, are we learning more for this unit, or
You'll learn more things.
Okay.
I'm just saying, I know from all the, there's typically 8 or 12 questions on the test. I remember this one in particular because it was, I counted because I was like, man, how bad was this? And more than half of the kids had gotten this one question wrong. That doesn't mean more than half the kids failed the test. Maybe this is the only question they got wrong and they still got an A. You know what I mean? But this one was hard. So all I'm trying to say is try hard on these, learn this part, and if you can get this, the rest of it's easy. All right, so I'm going to go start drawing my triangle for this thing. And I have the advantage of being able to zoom in infinitely. I don't think you guys can zoom in infinitely. It's one thing about displaying everything I really like. So I can make, even on a very small space, I can get tons of room. Okay. So this, I like to write it as tangent of some angle equals 4 over 3, because that gives me my, TOA. And then I know, is there a variable? Because if there is, I'd put it in the first quadrant. There is not a variable. Where is inverse tangent allowed? It's only allowed from here to here. So I'm crossing off this. And then this is positive, so then I can't be here. So then I have to be here. And TOA is opposite over adjacent. Ah, I'm getting close. 3, 4, 5. I know that one. Yay. Otherwise, I could have done it the long way and square root of 9 and 16, add them together, square root of 25. Oh, it's 5. All right, cool. So now, with that in place, that was the y part. Remember, this was the x part. This was the y part. So this is the y drawing. So technically, this is angle y right there. All right, so now I'm going to go find cosine of y. Cosine of y, adjacent over hypotenuse, 3/5. And sine of y. Sine is opposite over hypotenuse, 4/5. I think I just did that right. Can anybody verify that they got the same numbers as I did? Yes? Did you get 3/5 and 4/5? Okay. So then, I've told you before, if you have a common denominator, you're probably doing it right. See how I got a common denominator? It gives me hope that I probably did it right. They both have a 15 for a denominator. And this is plus, so I go 3 root 5 for this part and 8 for that part. So 8 plus 3 root 5 all over 15. Whew! That is a hard problem. All right. So now, special occasion, we have a worksheet for today. So, I encourage you to actually set aside your iPad. Just relax for a minute while I go grab your worksheets. There is homework problems in there that are good for practice, but this worksheet is the thing I really want you to do over the weekend. Have it done. Bring it completed on Monday. Okay? So there are other practice problems, but they're not required. The worksheet, required. That's all I got for the video for today.